Hello everyone. Let us now discuss today's LeetCode POTD problem. LeetCode question number 2290. Minimum obstacle removal to reach corner. Now I will be dividing this video into two parts: what, why, and how. In between this, I will be telling you the intuition, and here I will be giving you the algorithm and then the code. So what is given in the question? So simply they given a grid and we are having some obstacles here. Now we need to reach this destination. Destination is the last corner. So this is the destination and this is the source, or this is the start point. So the question given is we need to return the minimum number of obstacles to be removed so that we can reach destination. Simply, in simple words, we need to remove minimum number of obstacles. That means if these are any like doors or any walls, we need to break them and reach our destination. But wait a second. If you go through in this path, here we are getting one obstacle, here we are getting one obstacle, here one, and here one, and then we counted 1, 2, 3, 4, and we reached our destination. But instead of removing these all 4 obstacles, we can remove only these 2 obstacles and go to our destination. Let me give you another example. Here it is the destination, here is the start point. Now let us see this example. Now this source can go from here to here. There is no need to go through walls and break them. No need to break these obstacles. We are asked to remove minimum number of obstacles. Then don't go through these walls. That means how we can approach this problem. What is the approach for this? So they given that when we are at a node, let us say it is I comma j. We can go I plus 1 comma j, it may be here or elsewhere I plus 1 comma j, I comma j plus 1, I minus 1 comma j, I comma j minus 1. That means up, right, down, and left. So whenever you see such type of problems, either up, right, down, or left, and we are given with a grid, we can simply go with any searching algorithms. This is the like a method which we can use to search our destination. See how we can approach, how we can know that BFS or Dishketra algorithm is a better one. So let us think you are in Hyderabad and you should go to Mumbai, and there is and Delhi. So you can go directly with a flight from Hyderabad to Mumbai. There is no need to go from Delhi and then to Mumbai. That means we need a shortest path. But I am explaining a BFS algorithm here. But as I said, so this is the intuition behind our approach. Using BFS is our approach to solve this problem. Now, why we are using this BFS algorithm? To search minimum removals or shortest path. So imagine you are given with a graph. So here you are given with a graph. So imagine this is our destination and this is our starting point. You can go directly by breadth first search. One step here and second step here, and then in the third steps after these two we got our destination. But if you go with depth first search, you should go here, go here, go here, and you will be getting 1 2 3 4 5 6 these many steps, and then you need to go here and then the back and then to here. Maybe you can search from here, but as I am said, DFS is not the algorithm which we need in this problem. We need either BFS or Dijkstra algorithm. So wait a second. So we have completed with what is given in the question, and intuition is taking BFS or Dijkstra's algorithm. And why we are taking, we completed these three things. Now how we can approach this problem? Let me say, if you are at this source and these two are obstacles and this is an empty node, sorry, empty cell, and then we are having an obstacle here and then an empty cell and then an obstacle here. I just changed the first example. This is the destination and this is the source. So what do you think? Should we go here first or should we go here first? Let me say, if I went to this obstacle, so, and how we can solve this question? If you ask this, I should say, we also go through these obstacles. We go through obstacles. Keep this in mind. In other questions, we will be not going in these obstacles, but we go through the empty cells and reach our destination. But here, we will be going through our obstacles. Let me tell you in few seconds why. If you go here, then you need to remove this obstacle and then remove this or this. Here the count will be, even if you reach by here or by here, you will be getting the minimum obstacles that need to be removed is 2. That means if you go through obstacles, if you have obstacles as our first priority, you will be getting maximum instead of minimum obstacles. You will be getting the maximum obstacles. But say if you have reached this, if you have reached the obstacle, an empty cell, you will be getting only one obstacle when in which direction you may go. Only one here or only one here. You cannot go here. You cannot go either in a diagonal way. So you can go by this way and reach our destination. And here the obstacle which we getting in our path is only one. So our first priority will be an empty cell. Empty cell firstly. So in the question we have represented empty cell as 0 and an obstacle with 1. So our first priority will be an empty cell, that is 0. If grid of ij is 0, we will be taking firstly. But if you see, in BFS algorithm we will be using a queue. But here, if you use a queue, what will be the disadvantage? So queue will be having a front here and a rear here, and you will be adding all those in a mixed way. 0 and then 1 and then 0, 1, 1, 1. But as I said before, if we are having a source here and we are having an obstacle here and an empty cell here, so this is empty and this is 1. If you add 1 before 0, you will be getting more number of obstacles in our way. So to avoid that, 1 should be pushed from the last and 0 should be, if it is 0, should be pushed from front. So what is the data structure which we are going to use? Absolutely, it is a DQ. So you can push from front, push from rear, and you can pop back only the front. So I think you have got that into our mind that DQ is the data structure which we need to use to get minimum number of obstacles in our way. So if you got one, you will be pushing into the from the back, and if you got zero, you will be pushing from the front. So you will be using a DQ data structure. Then a simple BFS algorithm will be coming into our algorithm. Now we have completed what, intuition, how, and why, and how we can do that, and we came to algorithm, simple BFS algorithm. So you will, as I said, you will be using a DQ. Now into the DQ you will be having 0, 0. But why? 0, 0 is our first source, bro. That's why we will be using into our DQ as our first element. And after taking that 0, 0, absolutely we will be having a vector of int to get our directions 0, 1, 0, minus 1, 1, 0, minus 1, 0. These are our direction: up, right, down, and left. Maybe they will be in a mixed way, but these are the directions we will be going. Apply that to this source. Source will be with x and y, and new x, new y will be iterating from directions, and but wait, every time when we are using a binary first search, or breadth first search or depth first search, you will be using a visited grid to the actual grid. So here also we will be using a visited grid, but not like all other questions. We will be using int max here. You will get that in a few seconds. Int max. Why int max? So as I said, you will be having a 0 here, 1, 1, 0, 0, 0, and this is the destination. But when you come here, it is 1. But when you come here, and if you have all the path in a vector of int, you need to count all those iteration again. But instead, if I say add the previous element here, 0 plus 1 is 1, and then 1 plus 1 will be 2 here, and then 0, 2 plus 0 is 2, 2 plus 0 is 2, 2 plus 0 is 2, and here it will be, the destination is already an empty cell, then here it will be 2. So we got our answer. 2 is the minimum obstacles that need to removed in the first example. So visited will be helping us to do this. Visited will be helping us to know the minimum obstacles in our way to reach our destination. So instead of making it 0, you will be initializing visited grid with int max. So I think you are clear. You have know what is given in the question and how we are approaching with a DQ, and why we are using a BFS algorithm instead of another algorithms, and what is the algorithm using directions and iterating through them. No, as I said, in DQ, if we are having the right or left or down or new cell, if it is 0, as I said, it should be in the first priority will be the empty cell. If you clearly observe, first priority will be our empty cell. So push from front, and else if it is 1, push from back, and then this loop will be iterating till dq is not empty. So I think you got this, and I think it is not a super easy problem, but hard. But only the intuition which you need to get is not a BFS or a DQ, but taking the visited array with the previous one, that means 1 here and 0, and then taking the previous visited as sum to this element. That means a prefix sum. Maybe a prefix sum will be a better name for this algorithm for getting the minimum observations, and then you will be returning when you get to this. Here the visited of destination will be our answer. So thank you. I think I have explained well. If you if you like this video, then you can like and share to your fellow coders, and then subscribe to my YouTube channel. You will be getting POTDs every day, and I will be uploading minimum to 3 questions in every contest of LeetCode. So it will be more helpful to solve problems in LeetCode. Thank you.